I'm Elwin Wu, and one of the things that's sort of not mentioned but is worth pointing out is that to avoid building a house of cards, we want to make sure that the data are collected. All of this is sort of hypothetical or moot unless there's data to begin with. And so I'm really excited that to avoid building a house of cards and to have quality data that we can talk about and that we can address some of these issues is we have a panel focused on the plan and collect phase. Now, I'm a classically trained researcher at the Social Intervention Group at the School of Social Work here at Columbia University. And so I'm going to confess that as a classically trained researcher, when I read a new paper or I'm asked to review a paper, the first thing I do is go to the data. I look at the results. Then maybe I'll look at who did it or try to infer who did it. And that's really the meat of my work as a researcher and how I evaluate that. And so with that, I'm just going to sort of project how I kind of approach science and make sure that you folks have as much access to the conference data, if you will. That is what the speakers are going to be talking about and the panelists are going to be talking about. And I'll keep my introductions very brief. As a classically trained researcher, though, I also tend to focus on methods or make sure I spend a little bit of time on methods. And so just to make sure, I haven't had a chance to introduce myself to each of the panelists, but just to give you a heads up on the methods, I'll give you a 3-minute warning so that we can stay on time and everybody gets their fair share, or maybe in my research geek speak, I'm trying to enhance interpanelist reliability, if you will. So with that, I will keep my promise. Keep the introduction very brief. I'd like to introduce Joan Starr, who manages the Easy ID service for the California Digital Library and is the chair of the DataSite Metadata Working Group. And she will be speaking on supporting the research data lifecycle at the California Digital Library and the UC Curation Center.
Good morning, everybody. It's great to be here, and I'm really glad to join you. Thank you to all the organizers and the sponsors of today's event. I am going to be talking today about supporting the research lifecycle, research data lifecycle. First, I just want to spend a moment to introduce you to sort of where I am coming from. As mentioned, I am with California Digital Library, and we're part of the University of California. We serve all 10 campuses, which means we serve 226,000 students and 134,000 faculty and staff. The specific part of CDL that I'm part of is the University of California Curation Center, which is a partnership of folks on the 10 campuses at CDL and also in the community around, well, all of you and also other colleagues. And we've done that because we wanted to bring together people with lots of different kinds of expertise and experiences to meet the challenges in data management and data curation. And we think that in this way we are able to put together some new solutions and approaches, and I hope anyway that you'll be able to see some of those as I continue with my presentation today. All right, so at California Digital Library, we do actually use the research data lifecycle to inform how we develop our services and approaches. We think about this actually in a really active way. And so when I was asked to come here and talk with you, I thought, well, this is actually a pretty good fit. And so specifically, for example, in the plan component, we have developed something called the Data Management Planning Tool along with colleagues and partners, and I will touch on that this morning. In addition, we have a tool called Easy ID, which I will also discuss with you this morning, which is a long-term or persistent identifier service. In the collection space are some tools. First up, one called Data Up, which is an open source and web-based tool for data collection. as well as the web archiving service, which enables the collection of web content. Then for data management, actually the tools I have mentioned already, as well as the Merit Curation Repository, which enables the storage, management, and sharing of research data. And all of these tools facilitate the sharing of research data, and in addition, we partner with our colleagues in the eScholarship program, and that is a publishing platform, and we are beginning to work with them on data publishing solutions. So it touches a little bit on what David was talking about this morning. But since I've been asked to talk with you this morning in the planning and collection component, I'm going to focus in on those services. And so first up is the data management planning tool. This tool actually is really a tribute to collaboration in all kinds of ways. In particular, the development of this tool, which was put together by a number of partners: the University of Virginia Library, UIUC Library, Data One, UCLA, UCSD, the Smithsonian Institution, and our colleagues across the pond at the Digital Curation Center in the UK, and of course, California Digital Library. The Dmp tool, as you can see on the slide, it's a kind of wizard that researchers can use. They go in and can set up the basic data management plan that may be required by a funder. Right now, it's set up with quite a few of the funder's requirements. It can be configured with additional funder requirements. And the other thing that is really wonderful about this tool is that it can become a kind of gateway for librarians to talk with your scholars about the services that you have to offer in support of research data management, because you can get it configured to showcase your services. And lots of libraries have done this. It has been configured with tens of maybe 20, 30, 40, I'm not exactly sure because I'm not the service manager for this one, but quite a few libraries have actually configured it to showcase their resources. It has recently gotten funding, $590,000 from the Alfred P. Sloan Foundation, so look for this to actually become even more superpowered. I think of it as a really supercharged tool. Here's an indication of the take-up of this tool. It's really become quite popular, and so I really think this is a tool you might want to take a look at. I've brought some cards that are out in the lobby, I think, that you can take along with you if you want to remember. The URL's up in the upper left-hand corner, but you can pick up a card on your way out, and that'll help you keep it in mind, let's say. Oops, I'm really having I'm challenged. Here's my gizmo. All right, next up is EasyID, and I am the service manager for this one. This is a long-term or persistent identifier service, and I put it in the plan segment because long-term identifiers are not just for data citation. They are also a key tool in data management. We offer with this tool two types of identifiers: DataCite DOIs and also ARCs, and we'll be adding others over time. All right, I have to do an even faster presentation than I thought. And so this is something to mention in data management plans, and I guess I have to whip through these because I want to show more. Here's an example of data citation from Dryad. Here's what it looks like in Springer. But I want to give you a quick look at Data Up, which is a web-based and plug-in for Excel. And so what you do with this tool is you can upload an Excel spreadsheet, which we all know scientists use, even though they are, it's not really great for data curation. You can upload an Excel spreadsheet and it gets checked for best practices. It prompts you to save it in a repository. It assigns it an identifier and then prepares a citation. There are cards on this in the lobby as well. Here's the stats on how bad it really is, how much Excel is used. All right, here's Web Archiving Service, which is a tool that collection managers can use for collecting the ethereal web content. This is all these tools are available outside the University of California. This tool is for climate events, government documents that are now only available on the web, and so on. Here's an indication of how much this is being used. And since I'm running out of time, one more plug for how much we pay attention to the data life cycle. And quickly, if you want more information about this, we have lots of information about the data management planning life cycle. 2 different Twitter accounts for EasyID and DataUp, email, and also if you have other questions, obviously I had to do a really fast run through on these things, but you can contact me directly. And I look forward to listening to my colleagues and all the questions later. All right, thank you.
Our next speaker is Gail Steinhart, who is at the Research Data Environmental Sciences librarian at the Albert R. Mann Library at Cornell University. And she will be speaking on Research Data Management Service Group at Cornell.
Thank you to all the organizers for giving me this opportunity to speak with you about our experience in supporting data management needs of researchers at Cornell at the planning stage. So I will start with probably what's old news to everybody in this room, but it's one of the drivers for working in this area for us and all our peers, I think, and that's the evolution of funders' policies to increasingly require researchers to share the products of their research. So the announcement from last week from the White House is kind of a natural evolution in following on some policies that have existed for a few years. In the case of the National Institutes of Health, 5 years for open access to publications. For National Science Foundation, a two-year-old requirement to have a data management plan with every grant proposal. This new announcement now extends that so that every major funding agency in the U.S. pretty much has to, within 6 months, come up with a plan to guarantee open access to data and publications. So we have some work to do. But backing up to the original, not the original, but the NSF requirement for data management plans, when that came out, we began at Cornell to try and assess what kind of help researchers would need and whether they wanted help with data management planning. So we did a quick survey of NSF PIs, and I've just got selected results on this slide. Sorry, it's a little bit dark for this room. If you're interested in the whole survey, there's a paper on it in the Journal of eScience Librarianship. But my point here is that in the upper right-hand corner, there's a bar graph showing responses to the question, do you want help creating data management plans? And in all 3 graphs, the bars are in order from left to right, yes, no, and I'm not sure. Yes is the biggest bar, do you want help for planning? We asked a number of more specific questions about sort of researchers' understanding and practices when it comes to data management. Do your data conform to disciplinary standards? Do you generate metadata that conforms to disciplinary standards? And there are big bars over on the right for I'm not sure. And in fact, in the survey, for every question where I'm not sure was a possible answer, at least 20% of respondents picked that. So a lot of uncertainty and a real willingness to accept some help in this area. I know you can't read this one, and that's actually my point. So like any large research university, Cornell actually has a lot of services and infrastructure to help researchers do what they need to do, but it's widely distributed. So the teeny tiny text is categories of data management services and all the places on the Cornell campus where you could find that. And obviously researchers are interested in considering external services, things that come from their domains or maybe commercial services. So my point here is just that even on campus, it's a little bit overwhelming to sift through what's available. And personally, I wouldn't mind a concierge-like figure to help me sift through all that and find what's important. So this evolution in policies, uncertainty about data management, practices, and a sort of bewildering array of services that researchers might avail themselves of are really what prompted us to form the Research Data Management Service Group a little over 2 years ago. I just want to pull out a couple key points from our mission statement. One is that it's a collaborative campus-wide group. I'm with the library. There's a lot of library effort in this group, but it's really important for the success of this group and for researchers that this is not a library-only effort. The second point I want to pull out is that we really do bring people in from all over campus, which brings deep expertise from different disciplines, but also functional areas, so different aspects of information technology, policy, things like that. And then just the last 2 points are the two things that we really do, which is to help researchers create and implement data management plans, and then to help connect them with the research data management services that they might need at any point in the research process, whether that was part of a plan or not. So that's what we're about. A little bit about how we're organized. The main thing to know is that it is a virtual organization and it's a campus-wide collaboration, so there's no new office, no new units, no new staff. It's people kind of assuming some new responsibilities in the course of work that they already do. So the heart of the organization includes a management group, and the coordinator of that group is here. Wendy, maybe just raise your hand so people can chase you down later. And then representatives from the major service providers who are in a position to allocate staff and resources to get work done for the Research Data Management Service Group. And the people doing that work are on a couple of different teams, a group of consultants that I'll say a little bit more about, an outreach team, a documentation team that maintains the website, and then we convene and disband additional teams and task forces as specific issues arise. We report to the Vice Provost for Research and the University Librarian. We also have a faculty advisory board with ex officio members from the Office of Sponsored Programs and the Institutional Review Board, so we get input from all directions. So we make sure we really address what researchers need. And then in the background are all those service providers in the fine print in the black slide, continuing to do their thing as they always have, but perhaps having a little more business driven their way now that there's kind of a central point of contact for researchers to ask for help. And I think we're all developing a heightened awareness of each other's services and opportunities to collaborate to fill some gaps. So this is our consultant group. There are about a dozen of us, and like I said, we come from different disciplines, from different functional areas like geographic information systems, intellectual property, IT security, high-performance computing. I know some of our peers have chosen to have a smaller group of staff that are more exclusively focused on data management. This happens to work really well for us because of that breadth of expertise that we're able to pull together, and we're really able to match researchers with someone who can help them with their specific needs. All that diversity means we had to do a little extra work to make sure that we're all on the same page, since we do come from different disciplines, different professional cultures, and you know, at different points in time may have slightly different agendas. We wanted to make sure researchers have a pretty consistent experience when they deal with us. So the points that I want to pull out about the set of operating principles that we developed to make sure that we're all on the same page are, one, that we strive to do the best possible work in a timely fashion, and when you're dealing with grant proposals, of course, that means everything is really fast right now because it's due tomorrow. The second point I'd like to pull out is that we strive to promote best practices in data sharing, but we do that in a way that's pragmatic and recognizes the time and resource constraints that researchers face, and also with a healthy respect for the diversity of approaches that different disciplines take to research and research data. We, like I said, bring a diverse expertise to the table, but also are realistic about the limits of that expertise, and we'll refer people out when we reach those limits. And my next point about confidentiality is a really key one. We do sometimes need to talk amongst ourselves to provide the best service and comprehensive service, but that any information that we have about someone's research is confidential and stays within the group. We found early on, as we started consulting on data management plans, that sometimes someone would come to us for help and be a little bit reluctant to say much about the research that they're doing, and it's really not possible to provide substantive input to a data management plan if you can't talk freely with someone about their research. So it's crucial that we guarantee people confidentiality when it comes to research information. And then the last point is that we're not on commission. We refer researchers to the services that make sense for them. We don't privilege or preference Cornell services or any other services. We're really trying to do the best possible thing for researchers. So let me say a little bit about how the consultation for a data management plan would unfold. Most people reach us by a central help email address. And I think right away we all found ourselves receiving, being assigned a research consultation where the initial message told us nothing about the research that was being done. We're all writing exactly the same message with the same list of questions to get the conversation started. So we started sending an automated reply that asked a standard set of questions so that we could start this interview about what someone needs for a data management plan right off the bat, even before their request for help is assigned to a consultant. So the things that we ask for are, what's the call for proposals that you're responding to? It might have specific requirements we need to be aware of. What are your, tell us a little bit about your research. Tell us a bit about your planned data collection. Tell us about your publication plans, because some journals may have specific requirements, or they may support data publication, or they may have a partnership with a data repository that's useful to know about. And then what's your deadline? How much time do we have? And then we close with a link to kind of a general data management planning guide, because sometimes that's really all they needed. So we start collecting that information right away. And then these requests from help really run the range from, I need to submit a data management plan tomorrow and I don't have any idea what they're asking for, no further information. That's where this reply becomes really helpful. To here is my completed data management plan, could you please offer me some feedback? And sometimes those plans are very nice and thoughtful and complete, and then we see everything in between. And the consultation can unfold from there via email, phone, face-to-face meetings. Sometimes they're very quick if it's just a simple question, takes a few minutes. An involved consultation with extensive back and forth might take 4 to 5 hours in total, and the average is about an hour. So that's how that works for us. In 2 years, we've had over 100 requests for help. About 80 of those have been for data management plans from the National Science Foundation. And mostly we're working with scientists, life scientists, engineers, but occasionally social scientists and humanists find us as well. And I'll close with this, that the demand for consultations hasn't really slowed down since we started, although there's some predictable peaks based on peaks in submissions to NSF. So.
Our next presenter is George Alter, who is the director of the Inter-University Consortium for Political and Social Research, a professor of history and a research professor at the Population Studies Center at the University of Michigan. His presentation title is called Collecting Data in the Social Sciences, Planning for Sharing.
Thank you. Thank you very much for including me. Let's see. So this is a little bit about who we are. ICPSR celebrated its 50th anniversary last year. We were founded originally to share political science data, and now we've expanded to many other areas. We exist as a consortium of member universities, and we're now over 700 universities worldwide, about 400 in the United States. And what we do is we archive data, we curate it, we preserve it, and disseminate it, and we also teach people how to use it. So we have a summer program that last summer had about more than 1,000 participants. So we've been advising people in the social sciences about how to manage their data for a long time. This is the latest edition of our guide for data collection. It's the 5th edition. We now have put it up on the web so we can change it more often because things are changing so fast. And and as you can see, we have a data lifecycle concept there too. I'm not going to talk about everything that's in there. I've picked out some things that I think are problematic that I want to emphasize. So I'm going to talk about 3 areas: confidentiality and disclosure risk, provenance, and metadata, which are particular problems in our disciplines. So when we collect data, we promise people that that the benefits of collecting the data outweigh the harm, and we have an obligation to protect the confidentiality of the information that people give us. So there are a number of things that people could do to make their data more shareable in the area of confidential data, if they thought about them in advance. And unfortunately, I'm going to have to go through these things very fast, but I did want to mention some of them. The biggest barrier to sharing data in many disciplines is the informed consent process, because up till recently, many IRBs were telling people to use informed consents from the biomedical community that were really designed to prevent data sharing rather than to share it. That language is actually discouraged by NIH, and there are a number of things that people can do to avoid that. In our guide, we talk about some things that you shouldn't say, and we also have some examples of language that people can use. Secondly, this is an area that is not well developed, but we actually have I have a colleague who's doing a research project on this. There are a number of design features in the way that people collect data that make data more difficult to share because it's more identifiable. So there are a lot of things like geocoding, longitudinal data that are naturally make data harder to share. But people could reduce some of those risks if they thought about them in advance. So the simplest one, I think, is that if people take data from one geographic location, there are certainly some savings in costs there, but it makes it much more difficult to share it because the data is more identifiable. So there are a number of things that we're trying to develop to help people design safer designs to reduce disclosure risk. Finally, there are things that can be done to the data afterwards to reduce the risks of disclosure, and this has become quite a well-developed area. And there are strategies that people can use to share data that does have a risk of disclosure in safe ways. And one of the most important ones that we're working on, and a number of people not only in the US but in Europe have been working on, is this next to last one, what we call a virtual data enclave, which is a remote access system where the data is kept in a safe location, but you give people access to it over the internet so they can do their work. So provenance. One of the biggest problems in the social sciences is that we don't actually have a tradition of lab notebooks. If we had lab notebooks, we would be better off. People would be recording things. There are a lot of things that people should be recording under the heading of what a librarian or an archivist would call provenance that people don't think of that way, but I want to highlight that we need to train our researchers to think in this way. And I wanted to highlight one thing in particular that I think falls under the heading of provenance, which is response rates. If we're going to share data openly, the people using that data need to know the characteristics of the data. So, and this is a good example of something that's been of great concern in political science world and survey world, response rate. Now you see at the top there a national survey conducted by, it's actually conducted at the University of Michigan for I believe the CDC. And they've got a 78, 79% response rate. But there's another survey that we have in our collection where the response rates, are down in the 5% range. People wonder why many of the political polls predict badly. Well, it turns out that often they've got response rates that are under 10%. This has been a concern for them, and APOR, which is an association of polling groups, now has new guidelines for people to reveal these things. Well, capturing this kind of provenance information is extremely important. I wanted to say two things about about metadata. One is that in the social sciences, we do have a standard for metadata. In 1995, ICPSR met with other leaders in the field and began the Data Documentation Initiative. DDI, as it's known, is now gathering strength worldwide, not only in data archives, but also in some national statistical agencies. It is an XML standard for capturing metadata. And tools are now being developed both to use that and to the DDI metadata and to make it easier to collect. So for example, at ICPSR now, we have some new powerful searching tools that search at the variable level and will soon be able to search for studies that have 1, 2, 3 or more variables simultaneously, which are all built on having rich metadata. Of course, provenance is one of the elements in that, but a lot more is being able to have an automated codebook. There are tools currently being developed to assist people in putting their data into DDI, which makes the curation and the discovery much more powerful. At the moment, we don't have a full workflow that solves all the problems, but I think that that's coming. We're actually working on an NSF grant with two of the major surveys, the American National Election Study and the General Social Survey, to analyze their workflows to see if they can go to capturing the metadata smoothly throughout the whole process. Ultimately, I believe that that's one of the most important things that we can do for the researchers, which is to develop workflows and tools that, and DataUp is a good example of this, that assist them in capturing the metadata so that we have the full metadata. Because if the metadata is captured while the data is being collected, it will be more complete, it'll be part of their process, and ultimately the data will be much more useful. So thank you.
Our next speaker is Michael Huerta, who is the Associate Director of the National Library of Medicine and Director of the Library's Office of Health Information Programs Development. He will be speaking about the NIH initiative, Big Data to Knowledge.
Thank you, and thanks for this opportunity. I should say that I was asked to talk about what's new at NIH, so it doesn't really fit into the data lifecycle bin very well. So biomedical research enterprise today has lots and lots of data. NIH generates, with its funding, some $30 billion worth of data every year, but few of these data are broadly available to the research community. Now, there are exceptions like genomic data, the Human Connectome Project, and so forth. But by and large, the major public products of biomedical research are scientific papers and the concepts that they embody. So biomedical research today really is a concept-centric, not a data-centric enterprise. Tomorrow, we see a vision of having liberated data by increasing data sharing. We see advances in relevant data science and data tools, ways to make data discoverable, useful to others, citable, and linked to the scientific literature, and in general, raising the prominence of data in biomedical research, in science, and in scholarship. So how do we get from today to tomorrow? Well, about a month ago, the NIH announced its Big Data to Knowledge initiative for research data. And I should pause here and say, really, I think the first step this initiative will take is to take small data and turn it into big data, as David mentioned this morning, through metadata and bringing interoperability to the small data. But this is a much catchier title. So this NIH Big Data to Knowledge initiative started at the NIH Directors Advisory Committee. The Data and Informatics Working Group was formed, co-chaired by David Demetz and Larry Tabak. It issued recommendations for NIH research data in 3 categories: sharing and standards, tools, and the workforce development. And we put together 4 implementation groups under Eric Green, who is doing this as acting director of NIH for data science. It's a position that we are currently recruiting for. The 4 groups are sharing and standards, and the co-chairs and chairs are indicated here. Tools, Tools Plus, where the plus is data science, and workforce development. I'm going to go through these quickly and focus on sharing and standards in the last of these 4. So the tools will fund probably research project grants to develop data analytics, data management, and data processing tools. We're also looking at large-scale cloud computing for the NIH extramural and intramural researchers, and a way to dynamically engage software developers and users. In the Tools Plus group, we are looking at developing 15 to 20 centers of excellence to conduct research and provide resources in data science and big data. Workforce development will include training grants for institutions as well as short courses, curriculum development, and so forth. Now I'd like to turn to sharing and standards. Jenny Larkin at NHLBI and myself chair this group. We have 3 thrusts. The first is on policies to increase data sharing and to start changing the culture of data sharing in biomedicine. We see these changes as liberating the data, and they will essentially be an expansion and a strengthening of the data sharing policies that NIH has in place right now. The second thing we're focusing on is developing frameworks for community-based standards efforts. The notion here is if somebody comes to us with an idea for a research project, we have a framework. We have workflows, we've got forms for them to fill out, we've got budget restrictions, we've got this whole framework, and we've got support mechanisms, an R01 grant, for example. If they come up to us, however, and say, some leaders of this field have decided that what we really need is a common data format for functional magnetic resonance imaging data. What can you do for us? NIH doesn't have a framework. We can't pull anything off the shelf and say, here, this is how you proceed. So we're developing these frameworks, and we see that, of course, the standards will make the data more useful to others, and the community-based aspect will make these standards easier to adopt and promote. And the third area, and actually the focus of the rest of this talk, is the notion of a catalog of information about data sets generated with NIH funding. The idea here is to bring, through this catalog and the processes that I'll describe shortly, bring data into the research ecosystem so that it's discoverable, citable, and linked to the scientific literature. Each of these 3 thrusts adds value, I think, to the enterprise, and together they have lots of synergy, especially when coupled with the $100 million or so per year spent in the other parts of this initiative. So the NIH Data Catalog, I'm going to provide a use case. This is still in early stages, so this is the kind of thing we're thinking about. I think this will work, but it's not certainly a done deal. We're still working on this. It starts with an NIH-funded investigator. He's completed his experiments and has written up a manuscript, but before submitting that scientific paper to a particular journal, the investigator uploads a minimal amount of information about the data set to the NIH Data Catalog, which we see as an online resource, not unlike when you sign up for a conference and you fill out the little boxes and you hit the upload, that same kind of interface. would work. So the minimal information about the data set would include the authors of the data set, which may or may not be the same as for the scientific paper. And this, of course, allows proper credit to be given for data-related activities. You'd also have data descriptors pulled from a controlled vocabulary that will be developed. And because it's a controlled vocabulary and it will be curated and so forth, it'll allow for efficient search and retrieval of information about data sets. And the investigator would also have to provide information about where the data reside. You know, is it in GenBank? Is it on his hard drive? Whether the data are available for sharing, and if they're available, how to get access to those data. And this, of course, will promote sharing of data. Once the upload is done, it generates a data publication. So it'll have a title of the data set, the authors, a location in this data catalog in terms of referencing that publication. So that provides citability for information about the data set. And it will generate a data unique identifier. That data unique identifier will then be sent to the investigator, and the investigator will submit his manuscript to the journal with this data unique identifier in the abstract and with a citation to that data publication at the end of in the reference section, I guess. So the data will be cited as a publication because it'll be in the NIH Data Catalog. Now, when the paper in the journal is published, it goes to PubMed for indexing, and PubMed will pull out the data unique identifier and put it into a separate data element in the PubMed citation. And of course, the data publication will also be indexed in PubMed, and the same data unique identifier will be pulled out of there and put into a separate data element for the PubMed citation of the data publication. What this does is it uses this data unique identifier as a bidirectional direct link between the data publication and the scientific paper upon which the paper is based. PubMed will use the same controlled vocabulary for indexing as does the data catalog for describing the data set. What this will do is it will allow the same search terms in PubMed to be applied so you can pull up the same exact kinds of data sets from the data catalog. So in this example, one would go into PubMed, say you want to search on the NIH Data Catalog as the publication, indicate your search terms, and it would pull up whatever data sets have used those consistently curated search terms. And all of this information, the data unique identifiers and the citations, will be able to be ingested and used by NIH administrative systems for things like trends analysis and monitoring and linking publications to grants and to data publications and so forth. So overall, the Sharing and Standards group will be bringing data into the research ecosystem by making it more available through policy changes, by making it more useful by using community-based standards. Data sets will be discoverable through PubMed by these controlled vocabulary search terms and data definitions. Data sets will be citable because the NIH Data Catalog will produce citable data publications. And of course, once you have proper credit for data-related activities, as well as citability, that provides incentives for data-related activities. Data sets will then also be linked to the literature, again through PubMed, in general terms, through these search terms, these controlled vocabularies, as well as this bidirectional linkage through the data unique identifier. And finally, again, information in this ecosystem can be used by NIH and other third parties for all kinds of, I think, interesting analyses. And with that, I thank you.
Our respondent is Victoria Stodden, who is an assistant professor of statistics at Columbia University. She's also serving on several national committees, including the National Academies of Science Committee on Responsible Science, ensuring the integrity of the research process, and the NSF's Advisory Committee on Cyber Infrastructure.
Thank you for the opportunity to respond to this fascinating group of talks. So as people were speaking, I jotted down some ideas, so I'll do my best to summarize these in some coherent format. The first one that occurred to me as people were talking, especially right after, like we have the privilege of being right after the two keynote speakers, and so this in some sense can, I think, come into our discussion. I think a lot of this discussion really implies questions about values and about framing, and so this is also from the keynotes this morning, particularly issues on why we're sharing data. And many speakers have touched on utility and use and downstream effects and so on, all of which I am in complete agreement with. But I think there is a larger question here about notions of reproducibility and validation of results and verification. And I think this is really the core of why scientists and researchers are interested in sharing their data at all. And this can't be forgotten in the discussion. And if this becomes a discussion of open data as a good and an end in itself, it becomes extremely broad. And I think this is something that, at least in my background as a researcher, it's very difficult to wrap your mind around what this means. It also speaks to this question of utility as well. If we think about reproducibility as a framing issue, it opens the door to things like, well, how were these data used in research publications? It makes sense now to have this notion of linking to a research paper and linking to specific results. It also means that issues in terms of what methods were used in the implementation in software and how were these data actually implemented or turned into scientific findings becomes part of the conversation, as I think it should be. How have we managed to use this data, and are those tools then available to be used, to be inspected, to validate existing results? I think this is really a joint conversation between not just data that support published results, but also in the software and the methods and the code that was applied to the data to generate those same results. So this is thinking that comes from this framing of reproducibility. Coming down from that sort of high-level view a little bit and speaking more closely to the discussion this morning, I'm interested in things like how libraries and how the efforts that have been described here interact with existing repositories, like, for example, Archive. And we heard quite a bit of discussion from George about how this intersects with work that they're doing in ICPSR. This is something where a recurrent theme that occurred to me as people were speaking is, who's really responsible for what pieces of this puzzle, and how do they really come together? This is something that also reflects from the points this morning, where we had discussions of maybe this is something where the model should be Wikipedia-like, or maybe Internet Archive should be involved in this. Maybe it's something where there are institutional repositories that have been around a long time, or maybe they're involved in preprints or data. Library communities at institutions, how do they solve pieces of this puzzle, which we've seen a little bit of this morning? Where are the researchers involved? George said, essentially, if I'm understanding him correctly, we need to advocate for changes in the research process. This notion of this lab notebook is unfamiliar, and this is extremely important. Many people this morning touched on issues of provenance and workflow with data. This relates to this issue of the lab notebook, relates to this issue of how we do research, and also relates to issues of code and software that generated the results. So this all becomes part of the discussion. Where do the publishers fit in? Where do open knowledge community members fit into this? Is this something that is will just sort of come together as we do, or is this something that we really need a coherent discussion about values and about framing to structure the way that we move forward? All of these people that I'm mentioning will be part of the solution. Where do funding agencies fit in? And where's the model for how all these different groups work together? Where do community members give feedback into this? So if I'm a researcher and I'm using data that has been carefully structured and annotated and so on, how do I tell people that it didn't work? Is this something that goes through citation system? This is certainly something that is important. Is one of the arguments for open data, as we've heard a number of times this morning, is the fact that you can use data for research questions it was not originally intended for. It can be linked to other data. And so things like field-based standards and vocabularies and so on that people have been talking about, which are absolutely essential and important, there's no way they can extend to cover all these possible uses of the data. So how do you feed back in, and how do people say, well, this was effective, this needs to be updated, this was not clear at all? That's also, I think, something that is part of the discussion. So I think my main point that I want to make as respondent is not to get mired in the details, but also to have this higher level discussion that can help structure what is a very complicated problem with many different groups, with many different backgrounds and framings on how this is to be solved. What else? The other point that I wanted to make too is I see a parallel between researcher involvement in data sharing and in open data to researcher publication. And what I mean by that is many issues in the open access movement and things that people have been upset about stem from the fact that researchers do sign their copyright over to publishers, and they willingly sign this every time they're going to do this publication. Now, this is changing as awareness of the issue has really grown, particularly over the last few years. But I also see, particularly with all this hype and excitement about big data and data science and so on, and these collaborations with industry and data providers who, when academics were not the data collectors themselves, there are these very similar agreements coming out where data collectors, which are often big companies and like, Google, Facebook, who knows, like many, I don't mean to point fingers at anyone, there's lots of them. They'll offer these data, and with it comes agreements that you sign that say things like you're not going to share the data. And this is something where if we do the same thing that we did as researchers when we're publishing our papers and we just blindly sign without thinking and without pushing back on this, we'll be in this same situation with open access, with open data. And this is something where we should know better now with our experience with publication. And this also, I think, should be something that's in our discussion. And this is something that can come from this framing around reproducibility. So as a researcher enters into an agreement with industry, which can be extraordinarily productive, one of the things that should be discussed at the outset is, how do I make this work reproducible? Now, there are all these issues that were highlighted in our talks to do with confidentiality, to do with, and these issues can be worked around, but we need to default to this notion that it's going to be reproducible work. We are going to have open data. We're going to have open code and methods around this work when it goes to publication, and we can deal with exceptions, but the default is openness. Thank you.
Thank you. So we have some time for questions, comments.
If I could actually just make a comment on Victoria's response. She mentioned the need for not only data being available from scientific publications, but also the algorithms, the statistics, the software that was used in the analysis in a particular paper, for example. And I didn't have time, but we've got a software catalog planned as well, in addition to the data catalog, and that's a very important point.
I believe there are folks who will have microphones, so if you could approach them or signal to them and use a microphone for your question or comment, that would be very much appreciated and necessary for the broadcast.
Hello, I'm Daniel Kelto from Elsevier. Some of the speakers have mentioned this, but we know that universities aggressively pursue intellectual property. There are a lot of legitimate sensitivity issues, particularly around biomedical data and medical research data. And we also know that individual researchers it's very important to them to establish priority for their work. And we've done surveys globally. We've found that 85% of researchers say they want access to shared data. 48% of the researchers say they're willing to share their own data. Mm-hmm. So my question to the panel is, for the individual researcher, how do you convince them to share the data? Because they are often reluctant, dependent upon their field.
So that's a conversation I have practically every day, and a lot depends on the community. what we see is that this tends to go by communities in which people have done their dissertations on someone else's data, tend to be ones where people are more likely to share their data. Some communities have developed a culture of secrecy and emphasizing priority. There are provisions in our disciplines and I'm sure many others of what are commonly called embargoes. We prefer to call it delayed dissemination, but by which we can assure, we assure people that if they can have 12 months, and there need to be better standards among the journals and among the disciplines on when that clock begins, and what's disseminated. But it's something that I think has to be at the part of the community. Now, Michael's in a stronger position, being at a funder where the funders can say, yeah, you have to do this, but even there are ways that people can resist.
Can I?
Actually, if I could just build on that directly. So, at NIH, as you saw, one of the groups is looking to revise the NIH data sharing policies, increasing the breadth and the, but also making it relevant to particular communities. And I think that's an important part. And I kind of said glibly at the beginning that we're really moving from small data to big data. But that's true. So at NIH, we certainly do have big data. We've got NCBI filled with big data. And there are some other activities where the data really do interoperate and it would be considered big data by pretty much anybody. But most of that $30 billion a year is providing individual idiosyncratically configured data sets that will need to come together. And so I see BD2K as a major force in moving that process forward. And I also see the policy part of BD2K as not giving the ultimate, uber answer, but really moving that forward. And the way to do that, I think, is to develop data sharing policies that are community sensitive. And one way to do that, of course, is to bring peer review into it. So if a particular community is hesitant to share their data, or there really isn't much of a reason to share their data, maybe that peer review process will be a little gentler on them than if they're coming from a community where it's expected they're going to share their data and they're saying they're not going to. And I think at first blush you might think, well, that's not fair, but humans are humans and you have to do things that work with human behavior. And I think this way will take those communities where they're on the verge of wanting to share, and kind of push them over that barrier and bring in these other communities as well. So I think it's really got to be a comprehensive look. Sorry.
And they're extremely competitive.
Understood. Yes.
Actually, if I might share, at California Digital Library, I know I did kind of a speed dating version of a presentation of some of the tools that we've built, but I showed you really briefly mentioned Merit, which is our curation repository. We have built with that tool for UCSF medical school clients the capacity to create a configurable data use agreement. And that's a mechanism that makes some researchers have a feel-good experience about sharing their data. There's, I think, some questions about how enforceable something like that is, but it's sometimes just enough to allow someone to feel like, okay, I have a little bit of say over, at least, it's a trust arrangement with the other researcher who's using my data.
So one other point, if I may. I thought Joan would make the point about data cite and citation, which is another important thing here, and one in which the publishers can help. One of the things that we say to data providers is that if you give the data to us, we're going to put it up with the citation. We tell people how to cite data. We give the data a DOI, and you'll get credit for it. Publishers can help with that by creating standards for how data is cited and making sure that the data is cited in harvestable ways so that it appears in your scholarly index and Web of Knowledge and other places.
So to
I
the
don't need to make the point, we can just support.
To the question, how do you persuade an individual researcher who might be reluctant to share data? One question we hear over and over again is, which data am I supposed to share? And so in conversation with an individual researcher, I'll often start with, what's that publication date based on? And this then touches on the ideas that Victoria highlighted about reproducibility, and they understand that. They've shared representations of their data in figures, so it's not a huge step to move from sharing the figure to the data that were used to create it. So that's often kind of a door opener for us. And to the other point about universities' rather aggressive interests in intellectual property, yeah, we encounter that. And it's especially problematic for people who are developing open source software or equipment and have to deal with our tech transfer office, and it's something that all I can say is, yes, we struggle with that. So
I just wanted to make one point, actually following on Gail's point. The most compelling argument that I found is this notion of reproducibility. I don't think there's any scientist who wants to produce non-reproducible work, and that's something that is highly concerning to them. I have done some empirical work surveying scientists who've done data sharing and code sharing or haven't done it and so on. And I think this was also broadly reflected in the answers, that when there are direct benefits, like, oh, you'll have citation, and this does happen with data, and our standards absolutely should be better, but you can pick up citations. It's not that you put your data set out there and you'll immediately get scooped on your next paper. You usually get a few weird citations and so on from people who found uses for your data you didn't expect. And then arguments like this is good for science or this is something that will help people and so on tend to fall flat. This is something that the researcher really needs to see the direct benefit that they're gonna have from this. They may agree with all this other stuff, but everyone's under an enormous amount of pressure just to even keep their jobs and so on. So we have to be respectful of that. I think with regard to IP issues, this is a very serious problem at the institutional level, and traditionally tech transfer offices have been concerned with patents, particularly in biotech, and the notion that stems back from Bayh-Dole in 1980, and the notion was this is actually a means for enabling transparency, that the notion was there was all sorts of technology locked up there, and if we only gave universities and institutions rights over this, for example, patent rights and so on, then this could be much more transparent because we would have to disclose it through the patent process. So this is becoming a problem now because as we're sharing code and software as part of being reproducible researchers, now we come into conflict with a tech transfer office who says, well, maybe you shouldn't be opening that quite so widely because it's patentable, perhaps. And so that is something where I think we just need to take a very strong stance that if transparency is what we're about, then that's what we're about as scientists. If it's money-making for institutions, this is a different discussion. And I think that's something where, in 1980, we didn't have computational methods, and the legislature certainly weren't thinking about software patentability and these issues. But right now, in my experience with a number of institutions, the tech transfer offices are feeling out this issue, and I don't think they've come to any particular resolutions on it, and I think this is a good time to have this discussion and this debate. And it's not just about patents, it's also about copyright and ownership in software, and these are things where we need to be very clear that what we're supporting here is reproducible research.
Thank you. I want to make sure we get hear from a wide spectrum of folks. So I believe there's someone to my left.
Hi, I'm Carol Castle from NYU Libraries, and this question is primarily for Michael, because I was interested in your use case about a researcher who's about to submit a paper who then also submits their data. Because if the data is valuable in and of itself, then what happens if the paper isn't published?
Right. So first of all, they're not submitting their data. They're submitting information about the data set. So it's a separate process, and it makes the barrier lower. The idea with that is, and there are we've had different discussions about how this might be done. One could imagine that this would be done once the, so there are a couple of things. And I think a lot of this has to do with the fact that it was a kind of a shortened time scale here. So there's a lot of depth to this. We've also discussed allowing people to submit information about data sets that are never published in a scientific paper or form the basis thereof. And so in that case, it wouldn't be particularly problematic. I think that might be the easiest way to address the question. But our focus really is on the scientific literature published by NIH-funded researchers. That's our initial focus.
Any other panelists would like to respond to that? I believe there was a question back there.
I'll take it. Hi, I'm Mike Rossner from Rockefeller University Press. So again, I'll direct this towards Michael. You talk about you're creating a catalog of information about data sets. Where does the NIH expect the data sets to be? So
that's a separate issue, and it will depend on, for example, the data sharing plan. If the expectation is that the person will submit the data to GenBank, that's where the data will be. Right now, we have actually put together some 45, a website, a portal that you can actually access. I don't have the URL, I'm afraid. 45 large data repositories supported by NIH that accept data and that provide data to people upon request. And we would be using that kind of thing to encourage people to submit their data to large repositories. That's not going to be the case in all cases. You could imagine somebody generating a small data set that is not, there's no repository that exists for it. In that case, if the data are available for sharing, they might say, send me an email. Now, this gets back to my point about this whole thing being first steps. So that's, the ultimate answer would be, all data would have a home, and we're not there yet. But the idea here is working toward that. And I think that as this paradigm starts to change a little, people will see the need or not see the need for having repositories for certain kinds of data. So the answer is it won't reside in any particular place, but you will know where it does reside.
Hello, my name is Gerhard Klimek. I have 2 points. One to Victoria. It was sort of a slant remark on patents. I have a quote here. It says from the US Constitution, to promote the progress of science and useful arts by securing for limited times to authors and inventors the exclusive rights to the respective writings and discoveries. I would say a patent is a much better publication than what we normally publish. And it's expensive to do. That's the problem. The other thing is, this, what you guys are mentioning is incentive systems. Why should I share? And we are talking here a lot about data. Nobody so far has even mentioned the word on how others would actually truly utilize the data. What would they do with it? How do they generate a benefit and therefore generate a benefit for the originator of the data? There's a lot of talk on how expensive it is, but no talk on how somebody actually does something with it. What's the mechanics? How do they access it? Is it user-friendly? How fast can they access it? I mean, those are critical elements. It's usability to the end user, and therefore you generate value.
So let me address your first question. So that's right. So patents and copyright are in the Constitution, and they're certainly not going anywhere. But since that was written, there have been a number of acts that have reinterpreted and made that very precise and very specific. And what it means today is not, I think you might be misled about patent and copyright law if your source is the Constitution and not the subsequent acts by Congress. So I've never heard anyone say that they think a patent is a better scientific publication than a publication, and I'm presuming what you mean is perhaps it's more clear. I'm not 100% sure why you think that. But I'm reminded of the case that the Supreme Court heard, I guess 2011, Bilski, which was about business methods and software patenting, and one of the throwaway comments in that in that opinion was that of course, like, you know, if you write things mathematically, of course this isn't patentable because this is an abstract idea and not patentable. And to me, the way that I would read that, which just in casual conversation has been reflected by others, is that we actually want to obscure in patent applications. So yes, there's transparency, but you know, the smallest amount of transparency you can kind of give out is generally the most prudent way to submit a patent. And I would also make an argument that the Constitution is speaking about patents across all of society. I think how the scientific community interacts with this is very different from how profit-seeking business model, basically most people who are in the patenting world would interact with this. And so I would argue that right now this is a question that scientific researchers as a community are facing, that we do need to have some coherent discussion about this and sort out how we go forward. I mean, one idea that I've advocated is patent seeking and then patent licensing for industry application, and then just sort of free and open download and use of code for researcher application. So for example, if you wanted to validate results as an academic researcher or reuse the code, I just think for folks like this, if you have to call up a tech transfer office at a particular institution and negotiate this, it's like not sharing at all. It may be very different for the industry side. So I think there are a number of subtle points here, and it is patent and copyright, the IP issues are very important for us to address. I mean, we can, as researchers, put our heads in the sand because we are, you know, fundamentally a sharing open community. This is one of our core values. But when we start doing things on the internet and interacting with the larger community in this way, we are just faced with these issues, and that's a fact, and we need to address them.
So here's where I will do what George suggested and make the plug for DataSite DOIs. If you get a DataSite DOI, you implicitly agree that you will make your metadata freely available. And that means that when you follow one of those links, you will find what you need to get access to that resource that's been registered. And I think we'll be hearing from Heather Pivovar later today. She has done research showing that shared data gets cited more. I mean, she's shown that to be true, and so it's a direct benefit to folks that share. So, I mean, I'm looking forward to hearing more from her on that. And
you know, we have something similar with shared tools, and it's being cited in the literature, and we can prove it when it's shared, it's citable.
Right.
And in fact, that's the whole, I mentioned we also have software catalogs, and that's kind of a broad term we're using that we're developing at NIH, and that is part of the issue there. So the idea is to provide citability to the products of research, not just scientific papers, which we have now, but also data publications and software publications, if you will.
Anyone else like to respond?
Okay.
One more question from the back.
The issue on copyright seems like everyone's like, nah. But if it were me, I would write it down as a book, and if I couldn't draw it, I'd go on the street and get a comic book artist to draw whatever the patent is, and I would copyright it as a book or whatever. Because the problem with open sharing, people forget. I mean, people are going to Yale, they're going to NYU, they're going to all these medical schools, and they don't know that a black man invented open heart surgery. These are scholars. You understand? And then you have Einstein. Maybe it's not finished yet. You create the bomb, but maybe you want to create the unbomb before you release it as a chronic disease. So, again, Steve Jobs. Very few people know who Hedy Lamarr is. And she's the one that invented GPS and Wi-Fi. So, and leading up to that, there's this notion that you must be sitting in the university. Look what happened to our young friend here, 14 or whatever. Well, he was a little, preppy anyway, but besides that point, that he was outside of the box, inventing something. You have the notion that some inner city youth, some woman, some anybody can't get up out of the sewer and invent something fantastic, like open heart surgery. So, for me, in listening to you, I think it's very important that we know where the source comes from. Because unfortunately, the people who control data have came up with some very interesting things. Steve Jobs, Elvis Presley, all kinds of crap that is so far from reality and the origins of how things started that it is a danger to progress. What do you think?
So, I very much agree with you. One of the most exciting things for me personally about working in this space about transparency and open data, open methods, open knowledge is this notion that it's not open for people in the ivory tower. It's open. And this notion that and what undergirds that is this idea that contributions can come from anywhere and should, and this is extremely valuable. And one of our themes this morning has been, well, how do we give the right attribution for this and have that source information well known? And that's something that has concerned scientists from back when they started doing reporting in the 1660s. It's an imperfect system. I'm optimistic that this move to digital openness will help rectify this and allow people to learn the stories behind the inventions and behind the discoveries and understand how these things have evolved. So we're getting there, is all I can say. And I think this is really a step forward.
When we say cite the data, we mean attach an identifier to it so you know where it comes from.
Would anyone else like to respond? I think in this notion of sort of reproducibility is one of the advantages of data sharing and openness. I do think there's other aspects to what we're getting at, and that would be accountability and responsibility. And that is responsibility not just to other scientists, but to the public, to the community. Because that's what much of our science is for. As a social scientist and as a social worker, I feel particularly strong about that. And so with that, I'll take my privilege and really end on that note and that message, because I can't think of a more important message than that. Who are we as scientists ultimately accountable to? And it should be the public, society, and the community. So before we break for lunch, I'm standing between you and lunch. Please join me in thanking the panelists and the respondents.